Car is starting from rest, so its initial velocity is 0, and it is moving constant acceleration with constant acceleration, which means that its velocity is increasing uniformly, so delta v over delta t. Okay, and after traveling a distance t, the speed v, and at after this time t, what was the distance traveled and what is the time at this time? So you have to find out if it has completed the total distance d in the total time t, then at this instantaneous time you have to find out the speed of the car and the distance covered by the car. Okay, as I have already told you that this is a constantly accelerated motion, which means that its graph must be a straight line velocity time graph. So I have drawn this velocity time graph, and we assume that the car is starting from the reference position from the very start when its velocity was 0. Okay, and as you see, it's a constant accelerated motion, and in such kind of motion the displacement covered is always proportional to time square, because if you use this equation in which the initial velocity is 0, so this will be the relation that you will get from this equation, which means that in such kind of motion the distance in every interval of time will always increase. If the object here in the next second it is here, in the next second it will be there, and in the next second it will be there, so you see the distance is continuously increasing. So let's say after the time t it reached at this position whose displacement is t. So with the help of Suvat equations, we can find out the speed and distance at time t by 2. So the graph for this motion of the car must be a straight line as I'm drawing right now. So it must start from 0 because it was initially at rest. And you can also see that this graph is going straight to this point where it has covered the displacement t. Okay, anyway, so at what time? At the time t. For example, at the time t, if the velocity is v, okay, so the displacement is t. At the time t by 2, the velocity must be v by 2 because that is increasing uniformly, okay, right? So at the time t by 2, velocity must be v by 2. That's why the speed must be v by 2. Okay, now what will be the distance covered? Now you know very well that the area under the graph is equals to the displacement covered if this is a velocity time graph. So let's calculate the area under the graph. So what was the total displacement? For the total displacement, you can find the total area under the graph. I hope you understand. So point is, if you find this total area, like this complete area under this line, that will give you d. So 1 over 2 into v into t must be equals to d according to the question. And now I'm going to find out the area under this graph. So that must be 1 over 2. That is also area under the triangle. So 1 over 2 into v by 2 into t by 2. So what we are getting? We are getting 1 over 2 into vt. Can I take, if I multiply this 2 and this 2, it will be 1 over 4, and I'm going to take it outside, so 1 over 4. Okay, and you know that what is 1 over 2 vt? 1 over 2 vt is equals to the total displacement covered. That's why in this time the total displacement covered till the time t by 2 is d by 4. That's why the right answer must be A. So distance is d by 4 and the speed at this point is v by 2.